We're at ICA 1.3. Our goal is to use real number properties to simplify radical expressions. More simply put, what we're trying to do is add, subtract, and multiply radicals. This is probably going to get broken into two videos. The first video we're going to look at adding and subtracting. So let's take a look. When it comes to addition and subtraction, I like to think about radicals. So radicals are Clay variables. And here's what I mean by that. If I said 3x plus 7x, what would we end up with? Well, we'd end up with 10 x's. Right? So 3x's plus 7x's is 10 x's. The same thing, if I had 3x's plus 4y's, well, I can't add x's and y's. These are not the same, right? There's x and y are different, they have different meanings. So here, this is just simply still 3x plus 4y. Now, 3x plus 7x gives us 10x in the same way that 3 times the square root of 2 plus 7 times the square root of 2 gives us 10 square roots of 2. All right, so 3 roots of 2 plus 7 roots of 2 gives us a total of 10 roots of 2. If I were dealing with something like 3 roots of 2 plus 4 roots of 3, well, square root of 2, square root of 3, those are not the same. So I cannot then add those together. Now, what do I mean when I say clay variables? Well, clay is nice because you can mold and mend clay. So let's take a look at an example here. An example you might see would be something along the lines of 3 square roots of 3 plus 2 square roots of 12. Well, over here on my scratch work, I need to take a look. The square root of 3, I cannot mold that in any way, shape, or form. But the square root of 12, I can. So I'm going to take this whole thing, 2 square roots of 12. I'm going to take it over here to my scratch work, 2 square roots of 12. And I'm going to simplify that a little bit. Well, 12 breaks into 6 and 2 and 3 and 2. And my index here is a 2. So I know that I'm circling groups of 2. So I know a 2 is going to come out front. That 3 has no friends, so he's going to stay underneath. Well, I already had a 2 out front, so this 2 stays out front. That 2 comes out front, and the 3 stays underneath. And 2 times 2, that gives me a total of 4 square roots of 3. All right, so I took 2 square roots of 12, took it out, molded and mended it until I was left with 4 square roots of 3. So I take that 4 square roots of 3, and I want to plug it back in for 2 square roots of 12. So rewriting my example, 3 square roots of 3 plus 4 square roots of 3. Well, now that's easy. That's really easy. I have 3 roots of 3 plus 4 roots of 3. 3, 4, 5, 6. So I get 7 square roots of 3. And to be honest with you, subtraction works exactly the same way. So let's take a look at an example for subtraction here. Let's see. Let's try. Yeah. All right. So let's try the square root of 6 minus 2 square roots of 24. Alright, so the square root of 6, I know I cannot mold or mend the square root of 6. I can't mold that in any way. Then I look at the square root of 24. That has some, I know there are factors of 24 that I can mess with here. So I'm going to take just the 2 square roots of 24 over here to my scratch work. I said 2 square roots of 24. And now I want to break down 24. I end up with 2 and 12. I get 6 and 2, and 2 and 3. And my index, I know my index here, my index is still just 2, so I'm circling groups of 2. So these two here go together. That 3 does not have a friend, so he stays in the box. 2 does not have a friend, so he has to stay in the box. And again, this 2 started out front. I've taken care of the ends of the prime factors. So I'm going to take this 2, he's going to come out front here. This group of 2 comes out front as 1. And then I still have my square root of, and now 3 stays underneath and 2 stays underneath. So 2 times 2 is 4. 3 times 2 is the square root of 6. Alright, so now I have the square root of 6 minus 2 square roots of 24. I'm going to replace the 2 roots of 24 with 4 roots of 6. So I get square root of 6 minus 4 square roots of 6. And now this is where it gets a little weird. There's not a number in front of here. There's no number here. So recall, x is the same thing as 1x, right? So if there's nothing in front of x, we know that there's a hidden 1 there. Same thing with this. There's nothing in front of 6, the root, square root of 6, so I understand it to be 1. So 1 square root of 6 minus 4 square roots of 6. Well, 1 minus 4 leaves me with negative 3 square roots of 6.